Okay, we are starting chapter 10 today, which is the circles unit in your textbook. So the first section here is pretty much all vocabulary and middle school information about circles. Everything in here, none of it should be new. Okay, there's one or two things in here that you may not have heard before, but they're super easy things. We're mostly talking vocabulary. Okay? So, a circle. We've already defined that this school year. A circle is defined as a locus. That's a fancy word for set. A set of coplanar points that are equidistant from a single point known as the center. So it's a set of all points in a plane that are the same distance away from one single point known as the center. When we name a circle, we always name the circle based on the center. So here in this picture, the center of the circle is point C. So this circle is named Circle C. Okay, that is Circle C. But you could just write out the word circle as well. Doesn't matter. Either or is fine. Now in terms of line segments dealing with a circle, there are three types of line segments that are going to be important to us in this unit. The first is a radius. What is a radius? Half of the diameter, okay. What does it connect? The center to the anywhere on the circle, right? So a radius is a line segment connecting the center and any point on the circle. Okay, we are all familiar with the idea of a radius already. So really shouldn't have any big problem understanding that if I draw this line right here and I label this point A, then we would say that segment AC is a radius. Okay? Segment AC is a radius of circle C. Okay. Next up, we have the idea, and this might be new to a few of us, we may not remember this, the idea of a chord. Anybody tell me what a chord is? I'm not talking musical chords, I'm talking in a circle. What's a chord? It is a line segment whose endpoints lie on the circle. Both endpoints are on the circle. Okay? It is a line segment where both endpoints lie on the circle. Okay? So we just pick 2 points on the circle. Doesn't matter what 2 points. Let's say we use these two right here. We're going to call them B and D. If we connect those 2 points, B and D, with a line segment, that line segment, BD, is a chord. And then the third and final type of line segment that's going to be important to us is a specific type of chord known as a diameter. What makes a diameter different from a chord? It passes through the center. Okay, it contains the center. So diameter is a chord which contains the center. So again, what we're going to do is we're going to draw a couple points here. And we're just going to draw a diameter. Something like that. Call this point E and this point F. Okay, notice that point C is on that line. C is on line segment EF, which makes EF a diameter. Please note This is like the rectangle and square thing. Every diameter is a chord. Not every chord is a diameter. Okay? Every diameter is a chord. Okay, so then we try the example on the next slide. Name the circle. Identify each of the following using the diagram below. What is the name of that circle? Circle P. Outstanding. That is circle P. P is the center. We name the circle based on the center. So it's circle P. Somebody tell me a radius. PN? Sure. PN works. Give me another one. PM. Very good. There's one more in the picture. PL. Any one of those three segments would work just fine. Remember, those letters could be switched, and that would be fine as well. You don't have to name the center first. You just have to name the endpoints. Name a chord. There's only two chords in this picture. MN is the chord. And then there's LN, which is a chord, even though it is more specifically a diameter. Okay? So on your homework, you're going to be asked to name these things. You only need to give me one answer. It's like going back to when we were naming angles and such. Yeah? You only got to give me one correct answer. Everybody feel relatively comfortable that they can do that? Okay, then we come down to the radius and the diameter and how they're related. Again, we should all know this already. The radius is half of the diameter. So remember that we got the equation diameter equals 2 times the radius. And this is an important skill for your science classes. That equation could be rearranged to state that the radius is the diameter divided by 2, simply by dividing each side of the equation by 2. Yes? Those are the same equation. One is solved for diameter and one is solved for radius, but that is one equation, one relationship. The diameter is twice the radius is half the diameter. Okay? So in the example there, QV is 8 inches. How would we find the diameter? Yeah, QV is a radius. And its length is 8 inches. Since diameter is equal to 2 times the radius, that is 2 times 8, or a diameter of 16 inches. Okay, now I know I wrote a lot there, and again, this is because these are your notes. Your notes should always be more specific, more detailed than what you show me on your homework, so that when you go back and look stuff up, whether that's 6 weeks from now when you take your final, or 6 years from now when you're trying to make yourself a sign for your basement. I don't know. I'll never know when you're going to use the area and perimeter and diameter and radius and circle. You never know when you're going to use this stuff. Okay? Someday you come back to this and you want to understand it. Maybe it'll be in 15, 20 years when you're trying to teach your kids this. Who knows? Okay? You never know. You never know. That's why your notes need to be more specific. Are we good here? Let's get what we need so we can move on. Okay. A little bit more vocabulary stuff. 2 circles are only considered to be congruent if and only if their radii are congruent. So if GH is congruent to JK, then circle G is considered to be congruent to circle J. The opposite would also apply. The converse, if you will, would also apply. If G, circle G, is congruent to circle J, then that tells us that those radii, GH and JK, have to be congruent. If and only if. We got ourselves a biconditional statement there. Yeah, reaching back, aren't I? Look, there's a chapter 2 skill. Chapter 1 skill. I don't even remember how long ago we talked about that. Okay, both that statement, that conditional statement, and its converse are true. Okay, 2 circles are congruent if and only if their radii are congruent. What does congruent mean? Geometrically equal, same size, same shape, right? Same size, same shape. Now it's worth noting that we then went from talking about congruent triangles and we talked about similar triangles, right? So what's the difference between congruent and similar? Congruent means they're the same size. Similar does not, right? Just means same shape. Well, as it turns out, all circles are similar, period. Okay, all circles are similar. So circle X is similar to circle Y 100% of the time. Doesn't even matter. We could throw 18 more circles up there. They would all be similar. Circles are always similar. Always. Now, this last idea is a vocab word I'm fairly sure is new, and that is concentric circles, which are coplanar circles which have the same center and different radii. Now, here's why we're learning this. What's the name of the smaller circle? Circle A. What's the name of the larger circle? Circle A. Are they the same? But they have the same name, right? So that can be tricky. If you run into this issue on a homework assignment, the directions will state which one you're using for what. It'll say circle A with radius AB, that's the little one, and circle A with radius AC. So it will specify which radius. That's how you tell the difference, okay? But please note, both circles are named circle A. So I couldn't just give you this and say find the area of circle A, because there's more than one circle A. Okay, I would have to say find the area of circle A with radius AB. I'd have to specify which circle A I'm talking about. Okay? Concentric circles do appear on the SAT on occasion because they want to see how well you truly understand the idea. Okay, usually it's in the form of some sort of dartboard area question. Circles in a plane. Two coplanar circles can interact in three different ways. What I mean by that is it is possible for two circles to have 2 points of intersection, such as the top picture. Only one point of intersection. Notice it is indicated. Everybody see this one point right here? See how they've drawn a point to indicate that's the only place they touch? Because that sort of pictorial notation is going to be important. Okay, that's the only place where those circles touch is at that specific point. Okay? Or they could not intersect at all, which there's two different ways that can happen. They can either be completely separate or one can be completely inside of the other one. Okay, those may or may not be concentric. The point is, one circle's entirely inside the other. They do not intersect. Okay? Don't really have much to add to this slide. Any questions before we move forward? 0, 1, or 2 points of intersection are possible. All right, I want you to try this example then. The diameter of the circle S is 30 units. The diameter of circle R is 20 units. DS is 9 units. Find the length of CD. So, the piece of information that we do not need here is we do not need the diameter of circle R. It's unnecessary to the problem. Okay? If we're told the diameter of circle S is 30 units, then what is the radius of circle S? Good. 30 divided by 2 is 15 units. Now, the reason why we would care about that is CS is a radius of circle S. Yes? And D is between C and S. It would help if I wrote S. But C, D, and S are collinear points, right? So the segment addition postulate says that CS is equal to CD plus DS. Now, of the three lengths in that equation, we know two of them. CS is 15 units. You just told me the radius of circle S is 15 units. CD, we don't know. That's what we're trying to find. And DS is 9 units. How long is CD? 6 units. We would subtract 9 from each side of that equation. And that would give us the length of CD as being 6 units. Well, but you never trust the picture. Never trust the picture. Always trust the numbers. Okay? Never trust the picture, because some human drew the picture. Which probably means he drew it poorly. Okay? Never trust the picture, always trust the numbers. Okay? Pictures are great, they help us organize our thoughts, but you should never trust them. Okay? Last little bit of so-called new material is not new material, and that is the idea that circles, since they are not polygons, do not have perimeter. They have circumference, and we have two equations for circumference. We have diameter times pi, and we have 2 pi r. Those are both legitimate circumference equations. So the big thing here, and this is what the SAT will do if they ever ask you about a circumference, is they won't say, here's a circle with a radius 3, what's the circumference? They'll go the other direction. They'll say the circumference is 106.4 millimeters. Find the radius and the diameter. Okay? So to do that, well, we just pick one. Which one do you want to find, the radius or the diameter? Diameter, lovely. It doesn't matter. You can do it either way. Okay? So we set up our equation using the diameter version. Circumference equals diameter times pi. Then we plug in the number that they gave us for circumference, which is 106.4 millimeters, would be equal to this circle's diameter times pi. How do you solve that equation for diameter? Yeah, divide by pi. So then we'd go to our calculator and we would do 106.4 divided by pi. 106.4 divided by pi. And I am using the pi button, by the way. So that's going to give me that the diameter is approximately 33.87 millimeters. Really, I guess I should be doing approximately because I am rounding that number off. Okay, now I have the diameter. How do I find the radius? Divide 33.87 by 2. So the radius would be 33.87 divided by 2, or approximately 16.93 millimeters is approximately the radius. Okay, so we should be comfortable working forwards or backwards. Should not be a big deal in either direction. I would like you to round either to the nearest tenth or hundredth. Either one is fine with me. The problem itself rounds to the nearest tenth in the circumference, so tenth would be fine as well. What I don't want is I don't want you to round to a nearest whole, like less accurately than the problems in itself, and I don't want you to give me the entire number off your calculator. Okay? So there's a diameter and a radius. We got one more little bit. All right. The last little bit is this idea of inscribed and circumscribed. These are words we've got to be comfortable with. So, a polygon is said to be inscribed in a circle if all of its vertices lie on the circle. So if you look at the picture, see how all four corners of quadrilateral JKLM lie on the circle? J is on the circle, K is on the circle, L is on the circle, M is on the circle. Yes? We can say that JKLM is inscribed in circle C because all four vertices lie on the circle. Now, if we wanted to state that using the other word, circumscribed, that sort of means the opposite. Not really opposite, the reverse. Okay, that circle is circumscribed around that polygon, whereas the polygon is inscribed in the circle. I like to think of it as the polygon is inside the circle, inscribed, and the circle itself goes around the outside that's circumscribed. Okay, so circumscribed means contains. Inscribed means is contained by. Okay? And the reason that's going to be a big deal is for examples like the one on the next page. Okay, which again is an SAT thing that they're going to do on occasion. Okay? Inscribed, circumscribed. Any questions before we go to the... Okay, so a square with side length 9 units, 9 inches, is inscribed in circle J. Find the exact circumference of circle J. So first off, the polygon itself is what kind of polygon? It's a square, which means it is both equilateral, which somebody said, and equiangular. How big are each of the angles? I got you. The sides are 9 inches, and the angles are each, very good, 90 degrees. Okay? So when they tell us to do this, the dotted line in this picture is the what of the circle? The diameter of the circle. Okay. It's also a diagonal of the square. Yes? And if we got even more specific, within the square we have 2 shapes that we should recognize. We have 2 right triangles. So if we wanted to find the diameter of this circle, that would be the hypotenuse of that right triangle, yes? What can we do that allows us to find the hypotenuse if we know the 2 legs? Boom! Pythagorean theorem. So we're going to break out the Pythagorean theorem. To find the diameter, because that highlighted triangle there has told us that a squared plus b squared equals c squared, or 9 squared plus 9 squared equals d, where d is the diameter squared. Okay? What is 9 squared? All right, so we have 81 plus 81 equals d squared, or d squared equals 162. How do we find d? Square root. Very good. Now notice the directions say the word exact. So no decimals. You're not allowed to do that. Well, 162 is 81 times 2. So that means the diameter of this circle is 9 root 2 inches. Exactly. And for those of you that are more comfortable with special right triangles, we could have used the 45, 45, 90 triangle to come up with that as well. Okay? So the diameter of the circle is 9 root 2 inches. What's the circumference? Okay, 9 root 2 times pi. Very good. Your calculator won't like it, so you got to realize that that is 9 pi root 2 inches. Okay, that's exact. All right. Let me hand you homework on your way out the door.